I actually went ahead and started on this and didn't realize I was recording. So here's number 2. And I wrote out the definition. Every x has only one y. Uh, and I know this is beyond some kids, but this top function will not accept 2. It'll accept everything less than 2. So I'm only going to get one y value for everything here. The bottom function takes things that are greater than or equal to 2. So it's going to take a 2, a 3, a 4, and a 5. And it's only going to return one y value. This is a function because the x's are not repeating. That's good enough for y'all to understand. Now, if it looked different, so maybe you're not really sure what I mean by what I'm talking about. If it was g of x equals big old curly brace, what do we got here? 7x minus 4. And it said x less than or equal to 2, and then negative x plus 5, x greater than or equal to 2, we would have a problem because I would have to plug 2 into both equations. And if I did that, the top would give me 10 and the bottom would give me 3. I'd have this ordered pair 2, 10. 7 times 2 is 14 minus 4 is 10. And I'd have the ordered pair 2, 3. In other words, the x's would repeat. So I did that if statement there for you all to get some clarity on what I was trying to understand in words. Because I'm not allowed to place x into both equations, it's going to be a function. It's only going to have one output of y. 3 is graphing, and it says I need to see your tables, and you're supposed to know your mamas by now. That's what this is really about, is do you know what mama looks like? Like, you know, this is a upside down U. That's a U. And this is a line, right? So tables come into play. I'm going to make some tables here. First table is going to have input of x, and the output is going to be negative x squared plus 1. It's allowed to be between negative 10 and negative 3. Negative 3 does not have equality, so I'm going to go ahead and put a circle there because I can't actually put a solid point there. So if I plug a negative 10 into this equation, I'm going to get 100, but there's a negative sign there, plus 1, negative 99. If I plug a negative 3 into this equation, we get 9. The negative makes it negative 9. Negative 9 plus 1 is negative 8. Moving on to the next table. The input is x. The output is x squared minus 9. And if I plug a negative 3 into here, I'm going to have, let's see what I'm allowed to be both of these two. I can be that one. I can be that one. Cool. If I plug a negative 3 into here, I'd have 9 minus 9, which is 0. If I plug a positive 3 in, I'd also have 0. Now, this is supposed to be a parabola. I'm also going to plug in 0 in the middle, okay? Because this is x squared minus 9. If I plug in 0, I get negative 9. Think about the shifts. It's been shifted down 9 units. So I know these functions. When I look at something, I'm thinking about what it is. I'm picturing a graph in my head. That's what I'm doing. I'm using that visual space that I have available. The last one here that we get to graph has input x and output 2x plus 1. And interestingly enough, it's not allowed to be either one of these things. But we're going to plug them in so that we have places to draw, to connect to. If I plug in a 3, it's going to return 7. If I plug in a 5, it's going to return 11. Because 2 times 5 is 10, add 1, so forth. All right, now I get to graph this thing. Now, I am not going to be able to show negative 99, but I can go back 10. It's going to just be off the chart, right? Negative 3, negative 8. And the truth is, it's going to have to be a lot steeper. It's going to be off my screen. It's basically going to come in from way down there. All right, there's that piece. And it's actually going to be a solid dot there at the bottom. But anyway, somewhere down there, way off your piece of paper is a solid dot. This point right here, you'll notice the symbolism. has to be an open hole. All right, x squared minus 9. When I plugged in a negative 3, I got a 0 back. And I have equality, so solid dot. When I plugged in a positive 3, I got equality back, solid dot. And 0 lies between these numbers, and I got a negative 9. So it's also going to be solid dot. It exists. And very poor curvature on my part, but it looks something like that. And then the last one was the line segment. If I plugged in a 3, I got a 0. No, sorry. If I plugged in a 3, I got a 7. Plug in 3, I get a 7. I've got to open hole it because that point's not really there. If I plug in a 5, I get 11. 8, 9, 10, 11. Also open hold. So it looks a little something like that. And there you go. There's a piecewise graph. Kids don't like to make tables, and kids really struggle with, is it open or closed? I can tell you that. Given the function f of x is negative 2x plus 4, so long as x is between 0 and 8, and negative 5x plus 11 if x is greater than or equal to 8, is it increasing? There's some words missing here, but is it increasing or decreasing on such a fourth interval? So increasing would be positive slope, and decreasing would be negative slope. I wish I had better handwriting and just impatient as can be. So here's where we get A, and here's where we get B. We're going to use our formula f of B minus f of A, sitting pretty over B minus A. And I'm going to plug in a 10, and it's going to have to go into this equation because x is greater than or equal to 8. That's the issue with this one. Where do I plug in? Some kids will get that, some kids won't. So negative 5 times 10 is negative 50. If I add 11, I'm sitting at negative 39. The 2 gets to be plugged into the top equation because the top equation accepts values between 0 and 8. That'll be my f of A. So I have a negative 2. I encounter an x, which becomes 2, and then I add 4. And this ends up being 0. Now, this thing should be decreasing if you just look at the equations. They both have negative slope. It should be decreasing. But anyways, here's the math behind it. F of B is negative 39. I am taking away f of A, which is 0. I'm going to be sitting over 10 minus 2. And I end up with negative 39 over 8, which is definitely negative slope. That will not reduce, by the way. So decreasing is my answer. It is definitely decreasing. Decreasing. Moving forward in my life, here's number 7. You're supposed to write the function. So I like to start with domain. That's me. The reason I do this is because on a multiple choice test, identifying domain is huge. It is. If you can get the domain, you've probably made it go from 4 choices to 2 choices, maybe even the choice. Of course, you're probably listening to this video muted and have no idea what I'm talking about. That's a you thing. We'll just call this thing, let's go with h of x. Doesn't matter what you call it. It has 3 pieces, 1, 2, 3. And I like to start with domain. This one has a domain from negative 3 to negative 2, but not including negative 2. I get to be negative 3 because it's a solid dot. I don't get to be negative 2. It's an open hole. The middle piece, the horizontal line, has a domain from negative 2 to 1. Oh, I really messed that up. My head's not screwed on right today. I can be negative 2, less than equal. I can't be 1. There you go. I've never seen anybody write these out using intervals, so I don't do them. The third line has a domain from where x is 1 until x is 2. Symbolism is solid dots. They both have equality. There's your domain. Now, the rest of this is writing the equation. Some teachers teach this. Make it think mx plus b, all right? I'm okay with that. I am. I dashed it out. I followed the slope, and I can see that this thing passes through the origin. I am thinking about y equals mx plus b. The y-intercept is right there at 0. The slope is to fall 1, run 1, so negative x plus 0, or just negative x. The second piece, this guy right here, that's y equals a constant. That is a horizontal line. And anywhere on this, the value is 1, so hence just 1 inside. The third piece, again, if I see this thing, it looks like it's falling 4, running left 1. If I was to fall another 4, I'd picture myself right there. And that looks to be at negative 5. And I'm thinking y equals mx plus b again. B has been identified as negative 5. The slope is to fall 4 and 1 left, so negative 4. And there is that piecewise function in as good a way as I could possibly explain it. 9, write the absolute value function. G of x equals negative 2 absolute values of x minus 6 plus 3 is a piecewise defined function. The issue with this is mainly domain. Writing the equations is easy. It's the domain that's usually an issue. Algebraically, what you're supposed to do is you're supposed to figure out the x-intercepts and so forth. But what I'm going to do is I'm going to think about the graph. So let me pull this negative 2 out of it. Can I do that? I don't know if I should do that or not.